What visual content are crucial to support high quality views? So in this presentation, I'll endeavor to try to explain the importance of this question through research studies that we've been conducting here in Singapore, as well as try to tie this together with some of the current design challenges that are faced in standards in order to enable high quality views within buildings. Okay. So when we look at how daylight standards for buildings determine view quality, generally, two criteria emerge when we think about the visual content. So that is the features that occupants can see within the view, for example, the buildings, trees, roads, etc. So one criterion is horizontal stratification, which is used to describe the content of views that are separated into 3 unique layers by boundaries that run across their horizontal axes. So this allows views to be divided into a maximum of 3 layers, so foreground, landscape, and sky. And although views can be separated into a maximum of 3 layers, not every view will inherently contain each layer. So for example, a skylight may only allow access to the sky layer, while for example, a beach house with a view of the ocean's horizon may only have the foreground and sky layers. Another criterion advocated in standards is content distance, and this overtly describes the content that can be seen either nearby or distant to the view. So in the latest version of the European standards for daylight in buildings, the two criteria that were described are kind of presented in a tabular format. So the standard allows designers to describe the level of view quality based on 3 levels, so minimum, medium, and high. So to increase the level of quality, more layers need to be included within the view, and the content needs to be located further from the window. So designing for content distance is actually beneficial for 2 reasons. So firstly, objects seen further away will appear smaller, and this increases both the amount and diversity of visual information that's seen within the view. And secondly, to avoid problems of like eye strain, symptoms of myopia or nearsightedness, distant views allow occupants that visual relief following like prolonged periods where their gaze may be focused on, for example, a nearby object like a computer screen. However, despite these benefits, we actually believe that there's actually some uncertainty surrounding how these content criteria are applied within the design process. So for example, for some views, it's not always clear how the distance can be measured, such as when, for example, a window view, for example, has several high-rise buildings and their individual differences of each vary considerably from the window. We could also ask questions whether the criteria consistently promote high-quality views, even when there are pervasive issues, for example, of visual privacy. However, a larger problem surrounding these 2 criteria is the fact that they may not be able to differentiate between different content, in particular those that may be more beneficial to the occupants. So for example, given the benefits of nature exposure on human health, which William also just described now, it may not seem reasonable that high quality views should place nature at the same distance to other features that may be less beneficial to occupants, for example, a road with busy traffic. So therefore, we believe that these criteria need to be really carefully evaluated. So the following objectives were proposed with the overarching aim that was used to determine whether landscape distance affects visual satisfaction. So here, landscape was substituted in for visual content when describing distance, since the latter can also be interchangeably used to describe other features of the view. So the aim was filtered down to 3 objectives, which sought to kind of evaluate more concise questions about the window views. So first, how do we design views and measure it effectively using the landscape distance criterion that can be feasibly measured? So the importance of this is obviously to demonstrate an approach which can be applied to measure content distance within any complex view. The second objective questioned whether landscape distance would affect any given view, even when the number of layers or other features, for example, if the buildings are low rise or high rise. So if this criterion can consistently be applied regardless of the window view. And lastly, the third objective was used to determine if the differences in visual content influences the effects of landscape distance. So for example, if natural features such as greenery are embedded within the view, would distance still matter? So would it still improve view quality, or would nature suppress its effects? Okay. So to represent views seen from buildings, scenery across the National University of Singapore campus were photographed. So images allow for a wider, can you still see my screen?
Yes.
Okay, sorry, something weird happened here. So images, they allow for a wider and more selective range of views to be compared. And as a substitute for real windows, they actually provide better control over content-based factors. So for example, changes in weather, changes in daylight illuminance. So to measure landscape distance, a three-stage process was used. So in stage one, the landscape layers were identified. So generally, when we think about distant views, for example, these mostly are in reference to features that kind of protrude from the ground and are generally located within the landscape layer. So to identify relevant landscape layers, the method was informed by recommendations found in the Lighting Guide 10, which I've just provided a reference here. This kind of describes two junction points in the view located at the point where two adjacent layers may meet, often making the landscape layer the layer that is sandwiched between the ground and sky layers. So if any junction was absent in the view, the layers that were available were instead used. And although this approach may not capture every nuance for each view, what it does do is helps prevent small features, for example, like a nearby bush, from unfairly influencing the final estimate for distance. So in the example shown here, only one landscape was identified. However, in other views, more often than not, you would find that there's several landscape layers that can be identified using this similar process. So in stage two, the visual field was determined. So the camera focal length captured images using a 60-degree horizontal visual angle, which corresponds to the immediate visual field for binocular human vision. And using the camera original position and the focal length settings at the time the view was captured, this information could then be overlaid onto a plan view projection representing the position of the occupant and what they might see within the window. And finally, in stage three, the landscape layer can then be identified and calculated. So from the plan view perspective, two distances were identified, the minimum and the maximum. So essentially, these are parts of the landscape layer which are essentially closest and furthest from the occupant. And although in this example, the variability in the measurements given both indicate that the distances meet the high quality criteria in standards, it's actually quite easy to see how in other examples, the differences in the minimum and maximum may inadvertently change the interpretation of view quality given, depending on which extreme is used. So kind of overcome this problem, the median distance was used to determine average landscape distance. So to measure the effects of visual perception, survey evaluations were used to gauge the degree of satisfaction on different window views. There are three parameters that were measured. So the first was connection to the outside, which is used to describe the provision of outdoor dynamic information that the view offers in terms of time of day, weather, and any other temporal changes that may occur. The second was visual content, which describes what can be directly seen within the view, for example, trees, buildings, blue spaces containing water. And lastly, the third parameter was visual privacy, which describes the perception or feeling of observers being able to view you from the outside. One caveat when using images is that it's not often openly straightforward how connections to the outside and visual privacy may apply to static content seen in an image. So to kind of overcome this, respondents were asked to imagine these images were their real window view. And certain content, for example, a nearby road or a footpath, contain visual cues that might be representative of either good or poor outdoor connection or privacy. So 3 surveys were designed and included 18 images which were of interest to the research objectives. Each survey had the same images, but asked respondents to either evaluate connections to the outside, visual content, or visual privacy. So generally in survey research, it's often been shown among a small number of variables, there are strong ordering effects. And it's difficult to prevent responses from one question influencing the next, even after randomization, since respondents are more likely to remember the questions being asked and the responses that they gave to them. So to kind of completely remove it here, the 3 parameters were packaged into 3 different surveys, and different people gave their responses in each survey. 6 pairs of window views were kind of used to test 2 contrasting effects. 3 of them compared nearby and distant landscapes, or a direct effect, and 3 other pairs tested landscapes that had approximately the same distance, or a null or no difference effect. Across each pair, certain features, for example, the number of layers and general content, were kind of matched as closely as possible to provide apples to apples comparisons. So to determine whether landscape distance effects are consistent across different visual content, 2 reference visual images were used. So one was urban, showing nearby air conditioning units, and the other was nature, showing nearby plants. The differences or change in visual satisfaction between the reference views and 6 other views were calculated. And even though both reference views have like nearby content, there were expected to be differences in the results due to their inherent content. So it's generally expected that the differences for the urban reference view would be much greater, since the other 6 images had better views and more distant landscapes. But for the nature reference view, these differences were expected to be much smaller, and thereby revealing an effect that nearby content of nature can suppress the effect of distance. So to test these effects, an experiment was designed using an artificial window, and this backlit printed versions of each window view. Participants were recruited, and they were asked to give responses to the same three parameters used in the survey. And since the same responses were given in the survey to the same images, the data were compared to see if the same above-mentioned effects could be replicated. Okay, so returning back to the original question, does landscape distance affect visual satisfaction? Well, what can consistently be seen here is that as the landscape distance increases, people gave higher satisfaction for connection to the outside, visual content, and visual privacy. And these effects are consistent across every comparison comparing nearby and distant views, indicating that the effect of landscape distance applies to views that have a different number of layers and different scenery. So for example, views of low-rise and high-rise buildings. Well, this information cannot easily be used to determine or inform whether the actual distances, what these thresholds need to be in terms of placing them away from the window. What it does do, it provides evidence in terms of that this criterion can be used to promote occupant satisfaction. And the thresholds that are provided in daylight standards will likely improve the overall quality of these particular window views. So here, what we can see is that there are no apparent differences in satisfaction now. Therefore, if two window views have comparable characteristics, so in this particular case, the same landscape distance, they should receive similar evaluations of satisfaction. So the relevance of this is really to verify whether the same effect is present, even when we reverse the aim. So if we're able to find that there are differences in satisfaction when two views have different distances, it should be possible to find no effects on satisfaction when two views have the same distances. However, these results here and the previous ones plotted are really contingent upon comparable content seen across the window view pairs. So when we ask the question when two views have a single layer, which is nearby to the window but show different content, will these views both receive low satisfaction ratings? Well, the answer to this is actually no. So views with nearby nature can suppress the effect of distance. And generally what we show here is that there is no or very little difference in satisfaction when these types of views are compared to distant landscapes. However, this is not the case when the view has nearby urban features, since the distant landscapes will be rated higher. And these differences will generally show that there is an increase in visual satisfaction. So the importance of this is that visual content matters, and it determines, when we're considering how far features can be seen in the view, it does question whether or not the distance criterion can be consistently applied to a wider range of window views. Okay, so what do we learn from this exploration? So firstly, to surmise, there does appear to be an effect of landscape distance on visual satisfaction, therefore kind of supporting the idea that daylighting standards' decision to incorporate this as a criterion was correct. However, it might not always be able to leverage high quality views for every window view. So to uncover these effects, firstly, a new method to measure landscape distance needed to be provided, which can be used to measure even the most complex of window views. The approach itself can be used to overcome some problems that can currently be found, such as, for example, multiple measurement points and these measurement points having different distances for the same view. And using this measurement approach, we were able to find that landscape distance across a range of different views showed that when the distance of landscape increases, there's generally higher satisfaction. And while this finding aligns well with standards, we also find that it's actually not consistent for view content type. And these effects can be suppressed when the view contains nearby nature. Something interesting to raise here is whether the effects are suppressed by nature per se, or simply because the nearby content is visually pleasing. However, the finding itself is quite important when we think about the construction of new buildings, since not all new buildings will inherently have surrounding content that is distant. So for example, a dense urban city center with many neighboring high-rise buildings. So as a counter measurement, recommendations could be made so that views are strategically designed to incorporate more nearby nature when feasible and push urban content away as far as possible. However, with other research developments in the pipeline, other strategies could be put in place so when the distance criterion cannot be feasibly incorporated within the design process, other strategies may be put in place instead. So with that, I would like to thank you for listening.